We're going to work through problem 4.5 from Taylor's Classical Mechanics. This is a question on potential energy and work from chapter 4. So it's saying to consider a mass in a uniform gravitational field so that the force on the mass is mg, where g is a constant vector pointed vertically downward. So you can label this as the force of gravity is a vector, 0 x component, negative mg in the y direction as it's pointing vertically down, and 0 in the z component. So we want to show the work done by gravity moving from one point to another is negative mgh, where h is the height that is gained between points 1 and 2. So h equals y2 minus y1. And the work we know is the integral from that first point to the second point of our force dotted with dr. So in this case, we're going to have 0 and 0, and the only one that's going to matter is that y direction force, which is mg dy. We're going to go from y1 to y2, and this is just going to be negative mgy from y1 to y2, which is the work of gravity, negative mg y2 minus y1, which we determined y2 minus y1 is going to be our height gained. So we've proven and shown that negative mgh is the work done by gravity. So that's part A. Now we'll move on to part B. If we choose axes with y measured vertically up, the gravitational potential energy is U equals mgy. So we're assuming that U equals 0 at the origin, and we want to show that U equals mgy. Well, you can see here that our force is conservative as it is independent of path, and it's only dependent on the final and initial y values, so that height gained. So we can say that it's conservative. We know then that U of our final position here is going to be equal to the negative of that work done moving from initial y to final y. So in our case, we have our U is going to be equal to the negative of that work done that we just showed up here. It's going to be negative mgh, or negative mg y minus y naught, we can call it. And knowing that our potential energy is 0 at this point, and we're starting from y equals 0 perhaps, we get mgy. So we've gone ahead and shown that that will be the work done by gravity moving from one point to another is going to be negative mgh, where h is the vertical height gained. And we have gone ahead and shown that the gravitational potential energy at any point is mgy if we choose the y-axis to be measured vertically upwards.